In this recording, we are going to discuss number 24 in the statistics 1, math 1 to 2, unit 6, assignment 6, number 24. It says the volume of water per second reaching the mouths of Dominican rivers has a mean of 6. So the mean is provided and a variance of 2.25. Now remember, we have to square root the variance to get the standard deviation, because to standardize is x minus mu over sigma, right? So the mean is given and the variance is given. It says if the rivers with volumes less than x, less than means you've got to shade towards the left, is 0.9978. No, 0.9978 is not a tail. 0.9978 is a big chunk, okay? So if you have to shade towards the left, a value more than 0.5, you must start on the right side of the mean. Okay, so this clearly can show you that the value of x you have to find will be greater than 6. So I repeat, it says if the rivers with less than meaning you've got to shade towards the left, and you've got to shade a probability value which is more than 0.5, 0.99. So if you have to shade towards the left, a probability value which is more than 0.5, you must start on the right side of the mean. Okay? So this will be a positive z value. So your x value now will be greater than the mean. Your final answer should be greater than 6. Okay, because the x will be on the right side of 6. So that for it to shade towards the left, a value of 0.99. Now this is a big chunk, so you do not have to subtract from 1, because you can find 0.9978 directly from your table to get the z. As you know, you have experienced by now with previous questions, you need z so that you can solve for x, because you already have the mean, you have the standard deviation, okay? And you're going to use that probability value, get the z, and to plug it into this formula, the standardized formula, x minus mu over sigma equals z, and you can solve for x. You do not have to attach a negative sign towards your z value, because you're already on the right side of 0, okay? So this is kind of simpler than number 23. Okay, let's see if we get an example similar to it in unit 6. Example 5.11. Yes, we have to solve for x. However, our probability value that was provided is a tail, and we had to subtract from 1 before we could go to the table to get the z. And plus, we had to put a negative sign. No, that is number 23 I'm talking about there. Number 23. We had to put a negative sign to the z, because this is a left tail. So z was supposed to be a negative number. In this example, although it's a tail, but it's a right tail, so z is a positive number. So we do not have to attach an example, a negative sign to z. Let us see if there's another example. Oh, there's only one example. Let's see. An example higher up where you have to find x. Right. So example 5.1 is very similar to number 24. It says, a geologist is researching on the lengths of rivers in Dominica. He determined that the mean length is 17. The mean is given. The standard deviation is 5.8, so you don't have to square root. And he also found out that the proportion of rivers less than mean you have to shade towards the left. What value? 95.25%, that's more than 0.5, 0.95. So you have to shade towards the left, a value of 0.95. So you must start on the right. As you can see, here it is. So this example is quite similar to number 24. Very much similar. 0.9978 towards the left. 0.9525 towards the left. Okay, so here is your x. The x you're looking for. The mean is 17. You standardize, you get 0 for z. And here you have x minus 17 over 5.8. So now we can go straight into the table with 0.9525. to get the Z. Or also remember, you can use this little table there. It facilitates that process. 0.9525 is not there. Okay, it's not there. You have 0.75, 0.9, and so forth. So we go into the table and look for 0.9525. Don't have to subtract from 1. Here it is, 0.9525. So the Z now is 1.6. And let's go upwards, 1.67. That's the second decimal place. And as you can clearly see, here it is. Z is 1.67. You put it into the formula, the standardization formula. Here it is. So this working over there is just formality. Okay, it's not totally necessary. What is necessary is your curve, your X and your mean, your standardization, and then you go into the table, you find the Z, and you put it into the completion of the standardization, and you solve for X. So this working here is critical. Below here is critical. The curve is critical also, and all the rest is just formality. Okay, so you can use example 5.10 on page 20 to help you with number 24. Pretty much identical to each other.